Hi guys, this is Sakshi and I welcome you all to my EduTech platform, Way to Learn. So today's new subject is thermodynamics and statistical mechanics will be the upcoming one. So the first part is thermodynamics and our next session will be also on thermodynamics. So in this session we will be seeing around like important points required to solve a problem. And before we start this, let me tell you one important information which is given in the official website that if you haven't applied for June 2020 exam, now you can apply. The window is open now, so you can apply for June 2020 exam. You can fill in the application form and submit it. So, if you haven't applied, then this is your chance for June 2020 exam, which is going to be held around November. So, possibly around November. So, this was the information. So, if you or your friends haven't applied it, please pass on the information to others too. Just check on the official website for more information. Okay, so let us start. So, always when we start our any new subject, we just do a paper analysis. So here I have taken around from 10 papers from June 15 to December 19, and you can see that the 3.5 marks questions you can get around 3 to 4 and 5 marks question around 2 to 3. So basically you can gain 24 marks from thermodynamics. So all the subjects that I have like from classical mathematics and this now thermodynamics and statistical mechanics. So from this, you can surely gain around 30 to 50, right? Because this itself is 24, and around max is also around 24 or 30. So this makes 50 itself. But if you have been preparing along with me and have been solving problems along with me, then I'm sure that the first thing that you'll gain by writing this exam is 50 marks for sure, only if you practice your problem. So if we like solve more problems and if we go for further subjects other than all these three, then we can also aim for like 100 and so on. So let us go step by step. So for now, for the from these three subjects you can obviously gain 50 marks for sure. Okay, so topics that I'm going to cover from thermodynamics are the basic topics required, like the formulas alone required to solve a problem. Then the laws of thermodynamics, the formulas from those laws, and the Maxwell's relation and thermodynamic potential, which are very important. You obviously get one problem from them. And then the last thing is the problem. So I'll be giving the important points required to solve a problem, everything in the first three topics, and then later on I'll be solving problems. So I hope this will be useful for you so that you can make a note that these are your important problems in all those, and then you can obviously do the problems along with me. Okay, so let us start with the first topic, which is work done. So work done in a thermodynamic system is starts from the initial state to the final state, which is given as dW is equal to pdv. And you have to remember that the work done on the system is considered to be negative, and work done by the system is considered to be positive. And also, work done is also equal to the area under the curve. Area under the curve is from a PV pressure PV diagram. So let us see, and also that one important thing is the work done depends on the path. Okay, the path taken, not on the initial position or final position, but it also depends on the path it travels. Okay, so we'll be seeing problems from PV diagram, ST, like temperature, entropy diagram, and all those. Okay, so when we solve problems, we will see how to solve a particular problem if any kind of graph is given. Okay, it's based on problems, so we'll be seeing that in other video. So this is an important point required for you to know about work done, the formula, the work done on the system and by the system, the positive negative signs, and that the work done depends on the path. So remember this, work done depends on the path. This is going to help you in the upcoming videos. Okay. So let us see the cyclic process. So cyclic process is basically like if you start from an initial point and complete one round and reach back to the initial point. That kind of process is a cyclic process, and the work done in a cyclic process is equal to the area enclosed by that cycle. Okay. We will also see that what it is, this is just for your information. And okay, if the cycle traced anti-clockwise, so if you go anti-clockwise, then the work done will be negative. When the work done is negative, it is said to be the work is done on the system. And when the cycle is traced clockwise, then the work done will be positive, which says that the work is done by the system. Okay. So other important points, please note it down. Then next is the internal energy formula. Du is equal to dq minus dw. dq is the heat absorbed by the system, and dw is the work done by the system. And remember this, that internal energy does not depend on path. dq depends on path, that is heat depends on path, work done depends on path, but internal energy does not depend on the path. Important point to be noted. Okay, so these are some of the important formulas required. There is the Boyle's law, Charles law, and ideal gas equation, which is PV is equal to nRT. Okay, and average speed here is V average is equal to root over 8 kbt by pi m. You have to remember these three speeds: average speed, RMS speed, and most probable speed. And also know the relation between the three, that is which is greater and which is smaller. I also given the relation over here. Okay, so next is the law of equipartition of energy. It says that for any thermodynamical system, uh, there is every thermodynamical system has some sort of degrees of freedom. We'll just learn everything in the problem solving session. But first you have to know the important points, so that whenever you get a problem, okay, then you just have to remember, okay, this was something related to equipartition, or this was something related to internal energy, or like that. You have to know that before solving the problem. So for that, I'm giving you all these information here. So according to law of equipartition energy, every thermodynamical system has a degree of freedom, and that particular degree of freedom, that is, if I say I have a thermodynamical system and the degrees of freedom are 3, then my kinetic energy associated with that system will be 3 by 2 k by t. Okay, that is, each degree of freedom will have its kinetic energy to be half kbt. So there are, if there are 3 degrees of freedom, then my kinetic energy will be 3 by 2 kbt. Okay, and here u again is the internal energy, which is given in terms of degrees of freedom, n into half. Here n small n is the degree of freedom, and it can also be written as u is equal to n by t rt. Okay, and R is the gas constant over here. So Cv is given as dou u by dou t, specific heat capacity. Cv is equal to dou u by dou t, and Cp is also the same, specific heat capacity. Okay, specific heat. Okay, so with respect to constant volume, and Cp is with respect to constant pressure. So Cv is equal to dou u by dou t, which is given as n by 2 R, and Cp minus Cv, the relation between Cp minus Cv is equal to R. An important relation to note, and Cp will be as such when you use Cv in this relation. Okay, so let us see the ratio of the specific heat. The specific heat Cp and Cv. Though the ratio of them is given as gamma, and this gamma is equal to 1 plus 2 by n. Okay, n here is the degree of freedom. So, and the monatomic, diatomic, triatomic. For these kind of monatomic gas, diatomic gas, triatomic gas, I have given the degrees of freedom and the ratio of specific heat. These will be required in some adiabatic process from laws of thermodynamics. We'll be seeing where to use these values and why is this gamma used and all. Okay, so just note this down first. And next, this one is an important formula where the average translation energy per molecule is 3 by 2 kBt and average kinetic energy of gas is 3 by 2 nRT. Van der Waals equation, an important relation to know. And if you have any question which asks you to find the mean free path, then this will be the formula over here. And sigma here is the diameter of the molecule. Okay, if you, they will be giving you everything which is required for you to find. So sigma will be basically present, and mean free path is given by lambda. So in this session, this was the important concept, like formulas required to solve a particular problem. So in my next session, we'll be seeing like very more important and many more like formulas required, okay, to solve the problems from laws of thermodynamics. And then after completing the laws, we'll be seeing the Maxwell's relation. They are very important for you to know. Okay, so thank you guys. Like my videos, share my videos, subscribe my channel, share my videos, subscribe my channel, and also hit the bell. So do not forget to hit the bell, because only when you hit the bell, you will get notified for my further videos. So see you tomorrow. Tada!